Okay, so hi, good evening, everyone. Hello, are
Evening.
you there? Yes. Okay. Okay. Okay, very few people have joined, but I don't know that maybe they are joining or not. I'm not sure about. Shall we wait for 1 or 2 minutes, or shall we start? Okay. Okay, people are joining. Okay, I'll wait for 2 minutes and then maybe we can start. So, before starting today's session, I just wanted to ask you guys like whatever we have seen yesterday, have you guys gone through those content and tried to see things around that point? Or how was the yesterday session? Give me the feedback regarding that. That will be also fine. If you have joined the session, obviously. No, okay. So good session is that's not the thing. Like, shall I change the way I'm telling the things to you, or shall I continue with the same thing? Like whatever, like with the question, I will explain the concepts and yes, I understand. We should. You required some questions, right? I'll just add some more questions to the maybe by tomorrow or by day after tomorrow. They will send you the questions. Whatever the questions we have discussed already, and maybe add some more questions. Okay, and these are the questions from the previous qualifier. Okay, so similar kind of questions you can expect in the exam. It's there. Just give me a minute. Maybe I'll just. Okay, so before starting the session, maybe I start the session currently. That's fine. Maybe we'll see some of the questions from whatever we have studied yesterday. We'll see some questions regarding or corresponding to that, and then I will slowly start with week 4, and I'll go into week 5, 6, and 7. Okay. So let's start. So I'm going to share my screen now. Let others people join later on. Okay, all of you are be ready with pen and paper. I think you should also uh, okay. I'll just stop sharing my screen. Okay, this was one of the question paper which was given to you, uh, or which was there for the previous terms. Okay, probability I think we haven't covered, but okay, let's see today what are the things we already covered. Covariance and correlation coefficient, we will discuss it today. Okay, can you tell me? Okay, this is the question. All of you are able to see the question on my screen. Okay, somebody should speak.
Video. Yeah,
Yeah.
it's visible.
Okay, so an inspection team evaluates schools in different states in India. The grade awarded to each school depends on the marks given by the inspection team. 200 randomly selected schools in Chennai and Delhi were inspected by the team, and the data is given in table question table. This okay. So the data is here. So with this kind of statement, one more, I think one more concept I have forgot to cover yesterday was uh, sample. What is sample and what is population, right? And what is the descriptive statistics and what is the inferential statistics. So maybe with this question, I will touch those concepts also. So can you tell me what is the sample here in this data set?
200 randomly selected schools.
In Chennai and Delhi are the samples. Okay, correct. What will be the population? Or how to identify the population?
200 will be the population.
But so okay, so 200 randomly selected schools are there from Chennai and Delhi. That is a sample actually. So you can read the question from here. So this, see, an inspection school or inspection team evaluates schools in different states in India. So that means we are interested in evaluating the uh, schools from different states in India. So that means we are interested in a lot of states, right? More than two states or maybe, right? And in that case, what will be my sample? Sorry, what will be my population? All the states which are under study, right? So all the schools in different states. So maybe we are interested. So the population here will be population will be all schools in different states of India. That might be my what population, right?
Yeah, correct. Yeah.
Correct.
Yeah.
Fine. And what will be my sample? Sample is because I wanted, I'm interested in this study, right? To evaluate the schools, right? This is my interest, but I cannot go and I cannot go and collect the data of all schools in different states of India, right? It is possible, but it is very time consuming and cumbersome, right? So I cannot go there and I cannot select all schools and see what are the parameters are there, whatever things are there. I cannot go. So that's why what I'll do, I'll just select some sample, which is a few schools, randomly selected few schools from different states. So in this case, what are the what is my sample? It is 200 randomly selected schools, and that too from what? From Chennai and Delhi. Okay. Okay. So, okay, I'm not, my handwriting is not good currently, but bear with me. Okay, fine. So, the thing is, okay, this is population, then this is sample. But there is one more question that can this sample be a good representative of a population? Good representative of a population or a bad representative of a population? What do you think, that this sample is a good representative of a population or not? What's your opinion?
No, it's not a good possibility as we have only Chennai and Delhi.
Correct. So this is not a good representative of a population because we have just considered the schools from Chennai and Delhi, and we are not considering the schools from other states. And okay, in other state, that means we'll have a lot of districts, right? Different districts. So that means it's a huge uh, number of number of districts are more, and number of states might be, let's say if you select 10 states also, in that, like, I don't know, like maybe 300 or 200 more than that state districts will be there. And again, in those districts, a lot of schools are available. So if I wanted to have a good representative sample, what I have to do is I have to select the schools randomly. That is correct. We have to select schools randomly, but we have to select schools from all over states and all over districts. So let's say in each district I have to select maybe two or three schools randomly, and similarly I'll go to every state and I'll go to every district and I'll select the schools. In that case, my sample will be a good representative of a population, and I may be able to find a good inference about the, you know, whatever study we are interested in. That that inference will be, you know, what do you say, confidence. I mean, like, we'll be able to have that confidence that this study, whatever we have done or whatever inference we have done, that is good, right? So this might happen. You might have one more idea about the surveys, right? The election surveys will be happening by different news channels or maybe by other medias, right? So how they will do this kind of analysis and how they will come up to some inference before you know, election results come out. And you see, most of the times the election surveys, they will be very closer to the actual results, right? How it will happen. And is it possible that this media channels or maybe the uh, you know, newspapers or the survey agencies, they will go to each person who has given the vote, and after that they will ask them to which party you have given the vote, and like that, right? So it will be very difficult for them also, right, to go and collect each person's opinion and what vote they have given, and then based on that analysis they will show the results. It's not possible. So what they will do, they will collect a sample of, they will collect sample of people from different areas, right, where the election is happening, and they will select the people randomly. They will, on the basis of their opinions and other, okay, several other factors will be there, but all those factors will be carefully, you know, selected. And when you select those factors carefully, that will be a, if it is a good representative sample, then your results will be very closer to whatever actual results are, right? You understand my point? So okay, so these are the things. So this is called as, so based on the sample, if I wanted to predict, or if I wanted to, you know, predict about population, or if I wanted to find the inference about the population, this is called as what? Inferential statistics, right? So statistics means what? I have to find mean, maybe median, maybe mode, or maybe, you know, measures of dispersions like standard deviations, like that, or maybe the maximum or maximum of something, or majority force which goes to which country, or sorry, not which party, right? Or something similar studies, right? Okay, I'll give you one more example. Suppose I wanted to find the average score by a cricket player all over the world, and if I wanted to do that study, and I have selected 100 players from India, so whether that 100 players from India is a good representative of the population or not?
No,
No, right? So what will be my good good sample?
from every country, every playing country should data should be there.
Mayur, you are speaking on mute if you are speaking.
No, sorry. So I'll just start. Sorry. Okay. Uh, okay. So where are, so you understand the difference, right? Okay. So what will be my descriptive statistics then? Okay. Maybe descriptive statistics and inferential statistics I'll talk about later on. Maybe. Okay. Let's maybe we'll see this question. Okay. So I think you understand what is population, what is sample currently, and you understand um, what is a good representative sample and for a population for any kind of study. Okay, so this scenario, if you understand, this is the table which is given where the number of grades, so grades are given in one column and number of schools are given here. So what is grade represent here? So grade is a variable or okay, what is that? Variable or case, or what kind of variable grade is?
It is a categorical variable.
Okay, it's a categorical variable, right? Then what scale of measurement this
It's
grade will have?
Ordinal,
Ordinal.
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 Ordinal, right? Because there is some order
yeah.
in here, right? What about number of schools?
It's
Musical.
numerical.
Okay, that is fine. So yeah, that is correct. But current, it's numerical, that is fine. And what scale of measurement does it have? Ratio or interval? Since when we have
Interval.
numerical, we'll have why interval? We'll have
Ratio.
the absolute zero, right? Because zero number, we cannot have minus 2 schools, minus 3 schools, right? We'll have fixed zero, right? Either we can have 0 schools, that means no school is there, or we can have 1 school, 2 school, or like that, right? So it's a ratio scale of measurement. Okay,
Okay.
fine, but it's okay. This is okay, but I don't want the type of variable here. What does it represents actually? It represents the frequency, right? Frequency for the grades, correct? So there are 50 schools which are having grade A, right? Which got grade A. Similarly, there are 80 schools which got grade B. Similarly, there are 45 schools which got grade C, and similarly, there are 25 schools which got grade D, correct? So what kind of chart I can expect it from this data? Which is a suitable chart for this data? Whether this is a bar chart or pie chart or Pareto chart. So these are the 3 charts we have studied, right, in week 2. So which kind of charts do you expect it from this
Bar charts.
bar chart, right? Right. Because we are actually going to plot the frequencies, right? So for that, bar chart will be, a bar chart is useful here. But can we have pie chart? We can have pie chart, but it's not a best representation of this. So if I wanted to find the relative frequencies, or if I wanted to visualize or draw the relative frequencies, then I'll use pie chart. Why I cannot use Pareto chart here? So Pareto chart is nothing but a type of bar chart only, right? Pareto chart is a special case of bar chart, but I'll use Pareto chart when the data is nominal, because if I have grades which is a ordinal data, if I and in that case I need to preserve the order. Okay, I need to preserve the order, hence I'll go for bar chart. So okay, bar chart will look like, how it will look like, let's say I'll have A, B, C, D. I cannot change this order, right? A, B, C, and D. I cannot change this order, hence I have to go for a bar chart. So A will have 50 schools, let's say. B will have 80 schools. C will have how many schools? 45 schools, and D will have 25 schools. This is a bar chart, right? But if I wanted to plot a Pareto chart, how it will look like? It will have B here, right? Because it is having 80. Then I'll have A here, then it's 50, then I'll have C, then I'll have D. This also kind of it looks good, but the problem with this kind of chart is we are not able to preserve this order, right? This is now B, A, C, D. I don't want this kind of representation when I wanted to show it to someone else, right? So in that case, when there is a order in the, there is order in the variable, or if it is an ordinal variable, I will go for bar chart, right? I won't go for Pareto chart. I'll go for Pareto chart only when the data is nominal. Is clear? Okay, so I'm just giving you the some examples. These are not needed much here, but I just wanted to show you some concepts, because some kind of questions will be asked on these concepts. So I'm just giving you the hints regarding it. Okay. So can you tell me the answer to question number 5? Which of the following measures of central tendency can be computed for the given data? Mean, median, mode, or none of the above? What do you feel?
Median and mode.
Median and mode. Why? Because
Because mean does not
the-
mean
yeah, this is a categorical variable, and hence I'm restricted to median and mode only. Again, this is an ordinal variable, so I can have median also, right? If it is nominal variable, I will go only for mode, right? But this is ordinal variable, so I'll go for median and mode, and I cannot compute mean because this is not a numerical variable. Great, fine. So option B and C are correct. Okay, so question number 6 is, after the inspection of 200 schools, the inspection team issued a statement in the media that the grading of all Delhi schools is greater than that of the all Chennai schools. The statistical analysis that has helped to reach to the statement is, so is it a descriptive statistics or inferential statistics?
Inference. This is descriptive.
descriptive.
Why descriptive and why not inferential?
Inferential statistics because it predicts the result.
This is an inferential statistics. Why? Because based on this sample, what I'm going to do, I'm going to conclude regarding all Delhi schools, right? All Delhi schools are greater than that of all Chennai schools. So this is kind of an inference, right? About the population, right? Because we are just selected 200 random schools, right, from Chennai and Delhi, and still I'm able to predict or uh, infer about this statement, right? If it all like based on this 200 school, if my statement would be like this: after the inspection of 200 schools, the inspection team issued a statement in the media that grading of all these 200 school, like while inspecting this 200 school, will reach to that statement where the Delhi schools in our study is greater than, so the grades in Delhi schools are greater than that of Chennai schools. If I talk about only these 200 schools, right, based on my analysis, then it will be descriptive statistic. Okay, but here what we are going to do, based on a sample, I'm inferring about uh, the bigger population, right? So the or let's say, because we don't know, right, how many schools are there in Delhi and Chennai. Maybe there are 1,000 schools in Delhi and Chennai, and based on only 200 schools grades, I'm going to infer about all 1,000 schools in Chennai and Delhi, and hence it is a inferential statistics, not a descriptive statistic, right? So the inferential statistic will be a correct answer. Okay, maybe you have to go through the lectures in detail, so because we don't have that much of time to go rigorously into every concept, so I'm leaving all these things with you. Just go and see the lectures, maybe uh, or maybe we'll talk about, maybe whenever I'll get time, I'll just talk about this descriptive and inferential. Okay, what is question number 7? uh, I think we have answered this question already, right? It's bar chart. So option A is the correct. Okay, what about this question? Interquartile range. Can you solve this question? Take 2 or 3 minutes, and then I'll discuss.
Answer is 5, I guess.
Okay, so yeah, let's see then. So I think we have already discussed yesterday. So first of all, what you have to do is we have to arrange this data in ascending order, right? So it will be 14, then 18, then 20, then 23, and then 40, right? So to find IQR, what is IQR? IQR is equals to Q3, that is third quartile, minus Q1. Third quartile means what? It's 75th percentile, and Q1 is what? 25th percentile. So as
5.
discussed, yeah. So as discussed yesterday, how to find Q1? So n is equals to 5 here, p is equals to 25 by 100, which is 0.25, right? So it is, if the product np is equals to 0.25 into 5, which is 2.25, right? Or 1.25, yeah. This is not an integer, so I'll go for the second observation here, and the second observation in this data is 18. So my value of q1 is equals to 18, right? So q1 equals to 18. What about q3? Q3 is, to find q3, again n equals to 5 here, then p is equals to 75 by 100, which is 0.75, n into p, the product is 5 into 0.75, which is 3.75. This is not an integer, so I'll go for 4, and my fourth observation, which is will be q3. So IQR here is equals to 23 minus 18, which is equals to 5. So the correct answer should be 5, right? Okay, I think then we have covered whatever concept yesterday. I think I have finished all those. So let's go for correlation coefficient today, right? We'll discuss about correlation coefficient and maybe point by, so the association between two, you know, we'll see the association between two variables. Okay, I'll just add. I'll just so I'm going to talk about association between two variables. So I'm not going to cover everything, but I'll just cover the broad concept. So there will be three types of pairs. One will be one numerical variable and other categorical variable, right? Two numerical variables. So one is numerical and another is also numerical, and third is both are categorical, right? Categorical variables. So to find the association between two categorical variables, which are the concepts or which are the criteria are there? It is row relative frequency, right? Analytical things I'm talking about. I'm not going into this graphical summaries. I'm just going about analytical, how to find. So row relative or column relative frequencies. Okay. To find the association between two numerical variables, I have correlation coefficient. To find the association between a numerical variable and a categorical variable, I'll have point biserial correlation coefficient, right? Is it correct? Have you studied this first of all? Okay.
Yeah.
Have you seen these lectures regarding this? Because if I'm talking about this, what I'm expecting is at least you should know the nomenclatures, like what is correlation coefficient, what is point biserial correlation coefficient, or row relative frequencies and column relative frequency. So I'll not talk about row relative and column relative today. I'll just talk about correlation coefficient and point biserial correlation coefficient. Okay, we'll see some examples and then I'll jump to permutation combinations and then towards the probability. Okay, so let's see some example if I'll have. Maybe I'll take some example and different example. Maybe I'll come here. Okay, so this is the question. The phone brands of OnePlus, Vivo, and Oppo are owned by BBK Electronics. Table 4.1.g represents the data of the sales of OnePlus and BBK Electronics by different dealers in Chennai and Punjab. So the table which you have seen here, can you tell me what type of the variable of what type of variable is this dealer's location? Categorical variable, right?
Categorical, yeah.
Is it having nominal scale of measurement or ordinal scale of measurement?
Yeah, it's nominal.
Nominal, right? What about OnePlus?
Yeah, it is nominal data.
Numerical, right? Numerical.
Yeah,
variable.
Numerical, yeah.
And what type of scale of measurement it is having?
Ratio.
Huh? Interval or ratio?
Ratio.
Ratio, right?
Ratio.
Right. What about BBK Electronics?
Numerical.
And having ratio scale of
Ratio.
measurement. Right. So here you can see there is one categorical variable are there and two numerical variables are there. So if I wanted to find the association between dealer's location and OnePlus, which criteria I will use? Shall I use correlation coefficient or point by serial correlation coefficient or row relative frequencies?
Point by
Point by serial, right? Because whenever I wanted to find the association between a categorical variable and a numerical variable, again, why we are calling it as point by serial is because we in that categorical variable also only two categories should be present. So here you can see which are the two categories present in the dealer's location: Chennai and Punjab only, right? So only in that case I will be able to find the association between a categorical variable and a numerical variable. So currently here we can be able to find point by serial between dealer's location and OnePlus. What kind of association or how to find the association between dealer's location and BBK Electronics?
correlation.
No, dealer's location and BBK Electronics. So dealer's location is a categorical variable and
Point by
BBK Electronics point by serial, right? If I wanted to find the association between OnePlus and BBK Electronics, it will be
Correlation coefficient.
right. Okay, so let's start with correlation coefficient. So the data which should I use is OnePlus and of BBK Electronics. So can somebody take a screenshot and tell me the numbers? Take a screenshot of the screen and tell me the numbers.
walk with the order.
Have you taken the screenshot?
Yes.
Okay. Okay. So I'll have OnePlus. I'll have BBK Electronics. Can you tell me the values for OnePlus?
4,
4,
6,
6,
1,
1,
3,
3,
3,
3,
4,
4,
5,
5. Okay. BBK Electronics?
12,
12,
10,
10,
12,
12,
15,
15,
19,
19,
10,
10,
16.
16. Okay, fine. So I think yesterday we have seen about the sample variance and sample standard deviation and population variance and population standard deviation, right? So I'll just write out the formulas again. So what is the formula for sample variance? Summation of xi minus x bar to the whole square divided by n minus 1, right? What about population variance? Please. N, right? Sample standard deviation, it is root of population standard deviation, it is summation of xi minus x bar to the whole square upon n, right? So these are the formulas for sample variance and sample standard deviation, population variance and population standard deviation. So what is the distinction between a sample variance and a sample standard deviation? The denominator is having n minus 1 in sample variance and it is having n in population variance, right? That is a distinction, and we have seen one relation between sample variance and population variance also yesterday, right? Okay, now there is one term, similarly one term is there which is called sample covariance. Okay, so covariance means the variance between two variables. Initially when I found the variance, it was between only among only one variable itself, right? So this covariance term will come when I wanted to find the variance between the two variables, right? So sample covariance, I think I'll denote it by COVS. Okay, what is the formula for that? It is summation of xi minus x bar into yi minus y bar divided by what? Divided by what it should have? N minus 1 or n?
n minus 1.
N minus 1. Yeah.
Right, because it is sample, right? So it is what? It is a multiplication, or it is a sum of the product of the deviations of the individual variables, right? So suppose this is my x variable and this is my y variable. What I have to find? I have to find x bar for this, and I have to find y bar for this, and then I have to take a product of each of the term, and then I'll have to take a sum of it. So similarly, if I wanted to define covariance of or population covariance, what do you think? What should be the formula for it?
N instead of N minus.
Right? Okay, done. So this is sample covariance and population covariance. So the values taken by sample covariance and population covariance can be anything. Okay, can be any real number. Okay, can be any real number, and hence we it shows only the trend of the the trend between the two variables. So what does that mean by trend? Whether if one variable is increasing, similarly the another variable is increasing or not. It will show by the positive sign of the covariance, sample covariance, or maybe any covariance. Okay, if the negative sign is there, that means one of the variable is increasing if the other variable is decreasing, and vice versa. Okay, suppose x is increasing, then y should decrease. If this is the case, then I'll get one negative value of the covariance. Okay, but it will have the range between anything. So it can have minus 200, minus 300, minus 400, or maybe plus 200, or maybe plus 2, plus 5, something like that. It will have some number, but it will have the sign associated with it. And with that sign, what I'll be able to understand is if one of the variable is increasing, that means, and if the another variable is also increasing, that I will have positive sign to that value of covariance. Okay, but it does not give you how strong the relation or how strong the association between these two variables. In that case, what I have to do? So I'll have to find some other parameter, and that parameter is called as what? Correlation coefficient. Okay, and it is denoted by R. So R is correlation coefficient. Okay, R is correlation coefficient. And what is this formula? R is equals to what? Sample covariance divided by sample standard deviation of x into sample standard deviation of y, or it is population covariance divided by population standard deviation of x into population standard deviation of y. So just remember this thing. If I wanted to use sample covariance in the numerator, I have to use the sample standard deviations associated with those variables x and y. Similarly, if I wanted to use population covariance in the numerator, I have to use population standard deviations corresponding to x and y. With these two formulas, I will get the same correlation coefficient. So one more, so the formula, it will look like this formula. If I, you can try it out later. So it should look like this: x into xi, xi minus x bar into yi minus y bar divided by root of summation of xi minus x bar to the whole square into summation of yi minus y bar to the whole square. And with these two formulas, if I plug in this value here and this values here, I'll get same correlation coefficient. Similarly, I can with this also I can, you can, it's very, you can easily found out this formula. Okay, so this should be my formula. The correlation coefficient formula should be this. Okay, so that means if I wanted to find a correlation coefficient, what should I have? I should require this thing, right? The deviation of x, deviation of y, the square of the deviation of x, and the square of the deviations of y. So suppose this is my variable x and this is my variable y. How to find the values? So okay, once again, can you tell me the values? X and y. Somebody
Yes.
please. So for x is 1 plus, okay? 1
Yeah.
plus So BBK.
4,
4,
6,
4, 6,
1,
1,
3,
3,
3,
3,
4,
4,
5,
5. BBK.
12,
12,
10,
10,
12,
12,
15,
15,
19,
19,
10,
10,
16.
16. Right? Okay. So what is X bar? X bar is 4 plus 10, 11, 14, 14 plus 3, 17, 17 plus 3, 21, 26. 26 by 1, 2, 3, 4, 5, 6, 7. So it is okay. Some complex calculations are there. I won't do everything, but I'll just tell you what you have to do. So Y bar will be it is 94 divided by 7. So it is 13.42. So next step is to find x minus x bar, right? Division x minus x bar. Then I have to find xi minus x bar to the whole square. Then I have to find yi minus y bar and yi minus y bar to the whole square. So xi minus x bar will be 4 minus 3.71. So it is 4 minus 3.71 is 0.29. Then 6 minus 3.71 is
Sir, I think y bar is incorrect.
okay.
It is
What is y bar?
84 by how many
7.
numbers? Yeah,
7.
yeah. So that means 12.
12. Okay, fine.
Yeah.
Okay, fine. So yeah, so like this you have to find all the values. Then you have to take the squares of those values. So I'm not going to do because these are very complex. It's like only this squares and it will take a lot of time to solve this. Similarly here I will have y square will be 0, I think minus 2, 0, then 3, 7, minus 2 and 6. The squares will be 0, 4, 0, 9, 49, 4 and 36. So I have to take the sum of all these values. So it will be 7 plus 3, 10, 10 into 4, 10 minus 4 is 0, right? Oh no, sorry, 12. And this here it is 40, 99, okay, 40 and oh, how much? 89, 89 and 9 is 98, 98, 102, right? So I have to, okay, and some values will also be here. So this is what? This is summation of xi minus x bar. This is summation of xi minus x bar to the whole square. This is summation of yi minus y bar. This is summation of yi bar minus, uh, and I have to plug in all the values here so that I'll get the correlation coefficient. So if you check the answer, so this answer is I think the answer is between, it's a negative answer. So in that, what does, so I think this answer becomes something like that, minus 0.23 or something. Okay, I'll tell you about the how strong the correlation is. That thing I'll tell. You guys can later on solve this question and tell me the answer by tomorrow maybe. So to find the correlation coefficient, we have one line. So correlation coefficient will range from where to where? Minus 1 to plus 1. Okay, minus 1 to plus 1. So 0 to 1 and 0 to minus 1. Between 0 to plus 0.25 and minus 0.25, we do not have any correlation. No correlation between two variables. Okay, two numerical variables. Between 0.25 to plus 0.25, we'll have weak correlation. Between 0.25 to 0.75, we'll have moderate correlation. and between 0.75 to 1 we'll have strong correlation. Okay. Similarly, between minus 2.5 to plus 0.5 minus 0.5 we'll have weak correlation. Between minus 0.5 to minus 0.75 we'll have moderate correlation, and between minus 0.75 to minus 1 we'll have strong correlation. So what does this negative sign indicates here and positive sign indicate here? So negative minus 1 means what?
The values moves opposite.
Correct. So there is a strong correlation between x and y, and it shows that maybe if the values of x, one of the variables is increasing, the other variable, so the trend should be looking like this, right? If my data set is like this, or my data points is like this, right? So this will represent negative. So this is x and this is y. It will represent negative correlation, right? And if the data set is like this, if the trend is like this between x and y, it will show positive correlation, right? And how strong the positive correlation is, or how strong the negative correlation is, it will be given by these values, right? Is it clear? Okay, so try to solve this question then. We'll have this question. So since we do not have much time, so I'm just going somewhat faster. So find out the question number 4. Find the answer to question number 4.
Sir, can you share this PDF in the chat?
Hello. So what is the answer? Okay. Do you guys able to solve this question first of all? Hmm? What is the answer then? Okay, so I'll explain. Question 4 is X contains observations of the speed of a car and Y contains the observation of the speed of another car. Okay. And it is noted that each observation of Y is 2 times each observation of X. So if the sample variance of X is 64, then calculate the sample covariance between X and Y. So let's have some dummy data set. Okay. So let's say X is the speed of car and Y is speed of another car. So suppose there are speeds we have noted down. Let's say it's 30 kilometer per hour, 40 kilometer per hour, then maybe 45 or maybe 50, right? So or maybe let's say 25. So what will be my speed of car, the another car, which is car Y, let's say? It will be 2 times, right? So it should be 60, 80, right? Then what is 90 and 50, right? So from these observations, I may be able to find the covariance between this. So this is what the dummy thing, right? I do not know what is the speed of the car, but suppose if this is the kind of cases here, or maybe I can take x equals to x1, x2, x3, x4, and let's say the mean is x bar, and similarly for y I have, so y will be what, 2 times x1, right? 2 times x2, 2 times x3, 2 times x4, and then what will be my mean of y?
2x bar.
2x bar, right? Okay, until this point is fine, clear. Then if I wanted to find, and what I have given here is, maybe I think I have given here is sample variance of x. Okay, so let's say sample variance of x is x square equals to 64, right? So what is the formula for sample variance of x? It is summation of xi minus x bar to the whole square divided by n minus 1. Okay, so if I wanted to find sample variance of y, what it will be? Summation of xi, sorry, yi minus y bar to the whole square divided by n minus 1, right? So here you can observe one thing, n minus 1 and n minus 1 are same. So in the numerator, what will be the changes? So yi will be what? It is 2 times xi, right? Correct?
Right.
So it is 2 times xi minus, what is y bar? It is again 2
2x.
times x bar to the whole square upon n minus 1. So okay, maybe I'll write it here. So I can have summation of 2, I can take common, right? So it is 4 times, right? 4, right? If I take 2 common, then and I have to take a square of it. So 2 times, so 2 square. So it is 4 xi minus x bar to the whole square divided by n minus 1. So and if this is a sum, right? So then I can again take 4 common from each of the term, and I'll remain with summation of xi minus x bar to the whole square upon n minus 1. What is this?
X S X square.
Right. And what is the value of sx square? 64. So 4 times 64 is what? Sy square. Is correct?
Right.
Is correct or no? Okay. And another information which is given to me is what? Okay, no other information is given to us. It is just that x contains observations of y and y. Yes, okay, fine. And then we have to find the sample covariance between x and y. So what is formula for sample covariance? So this covariance of sample is equals to summation of products of xi minus x bar into yi minus y bar divided by n minus 1, right? Divided by n minus 1. So summation of, so again, fine, summation of, oh sorry, okay, they have asked for only sample covariance, huh? Okay, I think then if I wanted to find correlation coefficient, I may have used this value, right? But I don't think we are going to use this. Okay, any of this it's of no use or what? Okay, no, we cannot use this formula. Fine, we'll use some other formula. So I'll use the correlation coefficient formula. Okay, so let's say R is equals to can we use that also? I can use okay, it is sample covariance divided by Sx into Sy. Okay, so okay, one more thing we have to understand here is, let's say x is what, speed of one car, and y is speed of another car. So if I wanted to plot this data x and y, what will, how it will look like? X and y, right? So if x is 30, y will be 2 times, right? 60. Similarly, if x is 40, y will be somewhere here. So the slope will say something about the correlation coefficient, right? So are you guys able to understand this point? First of all, this is somewhat okay, I'm not sure, like do you guys, no, I don't know, like maybe I wanted to say that the correlation coefficient will be equals to 1. Why I'm saying this? Because whatever value of x is there, the double the value of y is there, right? So there is again like a strong correlation. There is like each of the data point. So if whatever value I'll take for x, the 2 times value y will take. So we'll have one straight line going through all the data points, right? So I think you have to understand the scatter plots maybe. So suppose we have this kind of scatter plot. If you have gone through the lecture, maybe it is very clear to you. So if x and y are there, what is correlation here for these data points? R equal to
Around 0.
0, right? Equal to 0, because there is no linear trend. Because what correlation coefficient shows is, it shows the linear relationship between two variables. If uh, if this kind of line will be able to plot through all the data points, it will have the correlation as R equal to how much?
-1.
-1, right? Because all the data points lie on a straight line. Okay. Similarly, if I have this kind of train and all the data points are like this, what is the value of R? It is +1, right? If at all we'll have this kind of data set, suppose this is my trend line and the data points are here. So what will be R? So it is definitely not 1. It is definitely not -1. It is not 0 also. It will be, so if you can say
0.75.
all the points are, no, not 0.75, some value, but it will, you can say it's a strong correlation, right? So it is between 0.75 to 1, right? Because okay, by visualizing this, I'm saying this, right? It's not, maybe it might be lesser than 0.75, but it is a positive correlation. I know that it's positive correlation, and it's a strong correlation also, because all the data points are very closer to the trend line. If some data points are away from the trend line, your correlation coefficient will drop down. Okay, but to understand the point, so my point to this question is, if I have this kind of setting, right, then my correlation coefficient is equals to 1, right? And in our case, we have known that whatever the speed of car y is there, it is 2 times the speed of x. So all the data points will lie on this straight line, correct? And hence the correlation coefficient is equals to 1. I'll use that information for my for my calculations, and I'll use here. So r equals to 1 equal to sample covariance divided by Sx is what now? Root of 64, right? And what is Sy? It is root of, what is this, 64 into 4 is how much? 256, right? 56. And so the covariance of S is equal to root of 64 is 8 into root of 256 is 8 into 216. So 16 into 2 is 8 is 256, and I think the answer should be 120. Okay. Have I done some mistake somewhere?
I think you have to divide it by 2 minus 1,
Okay,
right?
sorry.
Considering that x and y.
No, so 8 into 6 is, okay, sorry, this multiplication is 128. It's not 256. 16 into 8 is 128. Okay, so answer is 128. So do you understand maybe some concepts? So yeah, see, I think it's too much for you if you are not gone through lectures. That is there. Okay. Okay. Okay, so I think it's just very, I know like it's heavy for you, but maybe yeah, try to understand and try to cope up with the space. You'll have some time after this also to study. So I'm just giving you some difficult examples only. Okay. Okay, now maybe I'll talk about point biserial correlation coefficient. So the point biserial correlation coefficient is denoted by RPP. It is the association between a categorical variable and a numerical variable, right? And categorical variable of what? Having two categories. Okay. So the formula for it is RPB equal to y0 minus y1 bar divided by y0 minus y bar divided by, maybe I think it is sigma x, sigma y into root of p0 into p1. I'll talk about everything maybe through one example. I'll take an example from, okay, so there is no example here. Maybe I'll take one of the examples. Okay, leave it. Maybe I'll take example by, I'll try, I'll have my own example then. Okay, so let's say we are going to, so there is one, we are going to find the association between gender and salary. Okay, so genders are, let's say, okay, and name of a person, let's say Kavita, salary is let's say 20 lakhs, then maybe Mayur, and salary let's say 15 lakhs, then I'll have Shant, Ismail, and 10, have female, salary of let's say 15, and one more as okay. So this is the distribution of, this is the distribution, and I wanted to find the association between gender and salary. So what is gender? Gender is a categorical variable and salary is a numerical variable. What is my formula here? RPB, that's called point biserial correlation coefficient. Formula is y0 bar minus y1 bar divided by sigma y into root of p0 and p1. I'll tell you slowly what are these terms means. So this gender I will represent with x and salary as y. Okay, in that also I'll represent female as 0 and male as 1. Okay, 0 and 1. So if I wanted to find y0 bar, what is this? It's a average of female here. So it is average salary of female. So how to find average salary of female? It is equal to 20 plus how much? 15 by 2, which is how much? 37 point, sorry 37 17.5, right? What about y1 bar? It is average salary of male, which is equals to 15 plus 10 plus 20. So it is 15 plus 10 plus 20 divided by 3. So it is 30, 45 by 3, which is equals to 15. What will happen if I represent male by 1 and female by 0? So y0 bar will become y1 bar, right? And y1 bar will become y0 bar. That will happen. And due to that, what will happen? The sign of this numerator will change. Correct?
Yes.
Right?
Yes.
Yes.
So only the sign of this will change. Otherwise, the calculations remain the same, right? This is the only difference. So I'll go with this currently. So for our so I'm just representing female with 0 and male with 1. Okay. To find sigma y, what is sigma y? It is population standard deviation. Okay. So of y. So to find sigma y, what is how to find that? Summation of yi minus y bar square divided by n, right? This is root of. What is y bar here? It is 20 plus 15 plus 10 plus 15 plus 20. So it is 30, 30 plus 40, 70 plus 80, 80 divided by 5, right? 80 divided by 5, how much it is? 16. Okay, so the deviations are yi minus y bar is, the deviations are 4 minus 1 minus 6 minus 1 and 4. Square of the deviations will be 16, 1, 36, 1 and 16. And sum of all this is equal to 32, 34, 34 plus 36 is 40, 70, right? 70. So sigma y will be equal to 70 divided by 5, root of 70 divided by 5. So that means root of 12, right?
14.
Oh, sorry, 14. Sorry. Okay, root of 14. Now, what is P0? P0 is what? The proportion of 0 category. So, 0 category here, it is what? Female. So, what is proportion of female? There are 2 female out of total 5, right? So, P0 will be 2 by 5 here. If at all my M equals to 0 and F equals to 1, in that case, P0 will be what? 3 by 5, right? And P1 will be what? 2 by 5. But it doesn't matter, right? So P0 is proportion of female here, P1 is proportion of male here, which is 2 out of the 5 employees, or maybe two out of the 5 employees are male, and sorry, female, and 3 out of 5 employees are male. So if I interchange 0 and 1 also, it does not matter here because it's a multiplication, right? Only it will change what? It will change the sign, because sigma y is not going to change, y0 bar is not going to change, y1 bar is not going to, nothing will change, only the sign will change, right? That you have to understand. So whenever we'll ask, right, we'll ask for absolute value of point biserial correlation coefficient, and in that case the answers to all of you will be what? Will be same, right? Okay, so I'm going to find out the RPB value here. RPB is equals to 17.5 minus 15 divided by root of 14 into root of 2 by 5 into 3 by 5, which is equals to 2.5 divided by root of 14 into root 6 by 5. I don't know, like you can solve this, maybe this 2, so this is root 6 by root of 14 into 4. You can solve the value, whatever. Okay, I'll solve it. 0.32, right? Yeah, 0.32. Okay, again, the point biserial correlation coefficient, how strong it will show the correlation between or association between a numerical and categorical variable. Again, it is similar as that of correlation coefficient, and hence between 0 to 0.25 it will have no correlation, right? Between 0.5 to 0.25 to 0.5 it will have weak correlation. Between 0.5 to 0.75 it will have moderate, and between 0.75 to 1 it is having strong, right? So from this value, what you will suggest? Between gender and salary, it will have weak correlation, right? Or weak association. But can you tell me, does that matter if I say it is minus 0.32? No, right? Because here it is similar as that of there is no trend, right? This is because this is a correlation between a categorical variable and numerical variable. There is no trend which we have seen earlier for when we are seeing the when we were seeing the association between two numerical variables. So when negative sign is there, that means the trend is negative. So one of the variables is increasing, another variable was decreasing. If it is positive, then that means if one of the variable is increasing, the other variable also will be increasing. But here it is not like that, right? It is not like that. So we don't worry about the sign associated with the point biserial correlation coefficient. We'll just worry about the value. And I think the equation which I have given for RPB, right? You just use this one. We'll have one equation for when I have sample standard deviation here, but again we need to do some adjustment here, okay, and it will become complex. So what I'll suggest is use this formula alone. Even if you are given sample standard deviation, right? Just convert the sample standard deviation into population. How to convert that? With this sy equals to sigma y into what? Root of n upon n minus 1, right? We have seen yesterday, right? Okay, are you guys sleeping, or you are too much heavily loaded, or what is happening? You wanted a break for 2-3 minutes. Okay, maybe take the break of 2-3 minutes. Okay, and then because I wanted to go into permutation combinations now. So just okay, we'll start from 7:30. Okay, maybe I'll go 1 hour from here, and then we'll stop today. Okay, just take a break of 5 minutes. I will also take a break.
Hello.
Then we'll come back again.
Hello.
Yes.
Can you please just just review or repeat the last page which you have there?
Which one?
Whatever you just told about the
Ah.
association between categorical and variable. Can you please just repeat in a while?
The entire question or entire thing you're saying?
Entire thing in short.
Okay. See, the problem is I can explain, but you don't have much time, right? Maybe you can see it in the YouTube, right? We'll have this YouTube streaming. You can just go back again and watch it again. See, I don't mind repeating it. Yeah, I don't mind it, but still, I think it okay. Maybe I'll explain. So okay, I'll just go in one point. So we'll have 3 types of association. One is between two numerical variables, in that case I'll use correlation coefficient, which is equal to sample covariance divided by sample standard deviation into sample of x and y equal to, maybe I can use this one, right? Which is nothing but summation of the products of deviations of x and y divided by root of summation of xi minus x bar to the whole square into summation of yi minus y bar whole square. This is root. This is what? Correlation coefficient. What are the values taken by r? It is between -1 to +1. It's again between 0 to 1. So 0 to 0.25, no. 0.25 to 0.5, weak. 0.5 to 0.75, moderate. And here it is strong. So similar strain will be there between this. Okay. The only thing is the negative sign it shows here. If one of the variable is increasing, the other variable is decreasing, and positive shows that both the variables are increasing. Okay, that is the significance of positive and negative here, right? And the value for r will lies between -1 to +1, unlike of covariance. So there is a sample covariance. It will show the association between two numerical variables only, but it will only quantify it. It won't qualify it. Okay. So it will give like whatever the values are there, but it does not show tell me that whether there is a correlation between the two variables, whether that correlation is weak or whether that correlation is moderate or strong. That's why we moved to correlation coefficient. But what is the formula for sample covariance? It is the product of it is the product of the deviations of these two variables x and y divided by n minus 1, since it is sample. Similarly, what is population covariance? It is summation of, again same, it's product of the deviations divided by n, right? And the same formula we have used here, and if you plug in all these values, right, what is Sx? Sx is summation of xi minus x bar to the whole square divided by n minus 1 root of sigma x is equals to summation of xi minus x bar to the whole square divided by n, right? So these are the values of, and if you plug in all these things right here, you'll get the same relation. Okay. Similarly, there is one more correlation which is called point biserial correlation coefficient, which shows me the association between one numerical variable and one categorical variable. Okay. uh, and we'll ask for absolute value because here negative sign does not make any sense, and the negative signs comes because of we are assigning one values to the categories, right? So the formula for RPB is equals to y0 bar minus y1 bar divided by sigma y into root of p0 and p1. So here, what does represent y0 bar represent? It represents the average value of first category, okay, or one category, first category, or maybe one category, not first, one category, right? Average value of the numerical variable, okay, average value of a numerical variable of one category. Y1 bar represents the average value of the numerical variable of another category, right? Similarly, P0 represents the proportion of one category, P1 represents proportion of another category, and sigma y represents the population standard deviation of numerical variable. Okay, so here in our case, if you have seen this, we have gender as categorical variable, salary as numerical variable. We have two categories here, one is female, another is male. So I have represented female with 0 and male with 1. So when I found out y0 bar, that means I have found out the average of, sorry, here, average of a numerical variable. What is numerical variable here? It is salary. So average of this numerical variable, which is 20 plus 15 by 2, and y1 bar represents the average of another category, average of another category for of that numerical variable, right? The proportions here are, since there are two females out of 5, so the proportion of p0 is equals to 2 by 5, p1 will be 3 by 5. Sigma y is what? The population standard deviation of y, that you can find out if you, because this is only numerical variable here y, and hence we can find out the, you know, standard deviation of it. Okay, maybe it is, so I have gone through all this very fast, but you just see this, maybe you can see this page, this will sum up everything. Okay, just see to this page, 2 minutes, I'll come back. Okay, so yes, I think uh, we move to the next thing, which is convolution. I saw some questions. Okay, see, I know this is very fast. If you are not, if you haven't seen the questions previously, or maybe the lectures previously, it will become very difficult. But okay, we can't do much about it, right? Okay. So you can go through the YouTube videos and just try to solve these questions by your own after some time. Okay. Okay. Take one of the problem for permutation and combination. Okay, this is the question. Rohit wants to create a 4-digit numerical password for his mobile phone. In how many ways can he create a 4-digit numerical password between 4,000 and 10,000 with digits 0, 2, 3, 4, 5, 6 if no digit is repeated? Okay, this is the question. So how to solve this question? Okay, are you there, all of you?
Yeah, yeah.
Yeah.
Yes.
Okay.
Yes.
Okay, so that means I wanted to find the all the number of ways where between 4,000 and 10,000. So when I say between 4,000 and 10,000, that means will it include 4,000 and will it include 10,000?
No.
No, right? It will exclude. So when I have between, that means it will exclude the end limits, which are 4,000 and 10,000. That means I wanted number between this. So it should start, maybe the number should start from 4,001 and it will end where? 9999, right? Correct? Right. So that means how many digit number is there? The maximum 4 digit, right? So that means, and it is already mentioned in the question. So I need to set a password, a 4-digit password for the mobile phone, and for that, which digits I can use only? I can only use 0, 2, 3, 4, 5, and 6. Right? So the choices of digits are from 0, 2, 3, 4, 5, and 6, right? Okay. And it is a numerical password, okay, and it is a numerical password, and it should be greater than 4,000. Okay. So at my first place, which of these digits I can use? Can I use 0?
No.
No. Can I use 2?
No.
Can I use 3?
No.
Why? Because I wanted that number to be greater than
Then 4,000.
4,000. So that means my first digit, see, any password, right? Any kind of password, it will be a categorical variable, right? But here the problem is I should not start. So I should start with 4, right? Because my password should be greater than 4,000. So here, which of the digits can I use? I can
4,000.
use 4, I can use 5, or I can use 6. So how many choices are there for my first position?
3 choices.
3 choices, right? Okay. And for the second position, how many choices I'll be? So there, and one more information I have given is no repetition of digits is allowed, right? No repetition of digits is allowed. Okay. Okay. So I have used, I can use maybe 4 or maybe 5 or maybe 6. So only 1, 2, 3. 3 choices are there for my first position. Okay. How many choices will be there for to fill my second position?
5.
5.
Which are those? Either it can be 0, or it can be 2, or it can be
3.
3, or it can be one of this, right? 4, 5, or 6, right? Right. So I will not write that because I have used one digit already. I can use the remaining 5 digits here. So it will be 5. And for the third place,
4.
4. And for the fourth place,
3.
3. So total number of ways
3.
will be
180.
180. So that should be my answer. Okay. Suppose the question is repetition is allowed. In that case, okay, how many ways will be there to fill first position?
3.
3 ways, right? To fill the second position,
6.
6.
all the 6, right?
Yeah.
Right. For the second position,
6.
so sorry, third position, 6, and the last position also 6. So it will be 3 into 6 to the power 3. So that many number of ways will be there. Okay, I think that is fine. This is question. So with that, I think we have completed one question. Oh, sorry. Here only. Okay. Okay, question number 3. In how many ways can 6 team members, including a captain, vice captain, and a coach, sit around a circular table when the captain is to sit on one side of the coach and vice captain on the other side? So this is somewhat complex question, and this is the question of what? circular permutation, right? Correct or not?
Yeah,
Okay.
correct.
Have you studied about circular permutation first of all? Okay, it is the
Yes.
number of ways will be n minus 1 by 2 n minus 1 factorial by 2, right? Sorry, not no, if it is by 2 when the anti-clockwise and clockwise arrangement is similar. If it is not, then it is n minus 1 factorial. Okay. So there are 6 team members, including a captain, vice captain, and a coach. Okay, and they have to sit around a table. And the condition is when the captain is to sit on one side of the coach, and the vice captain. Okay, leave about this question. Maybe I'll give you one more question. Maybe that will be simple. So let's say there are 6 team members. Okay, including captain, vice captain, and a coach. Okay, and they have to sit in 6 chairs, okay, or in a linear table, okay, 6 chairs. How many ways are there that these 6 team members can sit on the 6 chairs? If the repetition is not possible because these are the distinct people, right? So repetition is not possible. How many ways are there?
6 into 5 into 4. 6
6
factorial.
into 5 into 4 into 3 into 2 into 1, which is 6
6
factorial ways. Okay. So the condition, if the condition is like this, when the captain is to sit on one side of the coach and the vice captain on the other side, what does that mean? That means, let's say coach is always in the middle, and captain is on one side and vice captain. So I'll write VC, I'll write C. So this should, or else what? Like this, right? And these three should be together, right? So can I say captain, vice captain, and coach as one unit? Okay. So total, how many people are remained in?
3.
3 and this one 4, right? So in how many ways I can arrange these 4 people?
4 factorial.
4
4
factorial
factorial.
into among themselves. How many ways are there? Either this vice captain, coach, and sorry, captain, coach, and vice captain. So there are these 2 ways, right?
2
Or
factorial.
maybe I can say 2 factorial ways. So I have to multiply this with 2 factorial, right? So this is the answer, right? So whatever the answer is, this clear,
Yes.
right? This clear. Okay. Maybe one more thing, one more question you might ask is, suppose there are these 6 team members, including captain, vice captain, and a coach, and we have said that always captain, vice captain, and a coach will sit together. So in that case, what will be my total number of ways of arranging these people, these 6 people? So captain, vice captain, and coach, they should be always sitting together. So uh, I can see captain, vice captain, and a coach as one unit. So total number of people I can say is 3 plus 1 again, right? There are 4. So how many ways these 4 people can sit? 4 factorial ways. And these 3 people internally can be arranged in how many ways?
3 factorial.
3 factorial.
3 factorial ways, right? So do you understand the distinction between these two answers?
Sir, can you repeat the 4 factorial into 2 factorial part?
Okay. So so here the condition was the coach should be in the middle, right? Because the vice captain should be on one side and the captain should be another side of the coach, right? So let's say, okay, so let's say we have these 3 places, okay, and I said that the coach should sit in the middle and the captain and vice captain will sit on one of the sides of the coach. How will you arrange these two people, captain and vice captain? So there is one way that vice captain will be this side and captain will be this side, right? And another way is, hello,
Yes, sir.
you are understanding?
Yes, yes.
These are the only two ways, right?
Right.
That means I have fixed one position here, right? And I have to arrange these two people in another two positions. So if I wanted to arrange these two positions and this position, if I already fixed, how many possible ways are there to fill this
Yes.
position?
2
Two,
factorial. Yeah.
and into 1, which is 2 factorial, which is nothing but these two ways, right? This is what I have showed to you, and if you wanted to do with this way, it is 2 factorial ways. Okay, so the other people, right? The other there are other three people are there, right? Three team members are there, and I have said this 3 as 1, right? So I added that 1, and the remaining seats are filled with 4 factorial. Do you understand? Okay, why do you understand why this 4 factorial is coming?
Yes, sir, because other
Even though
yes.
there are 6 seats, right? Even though there are 6 seats,
No.
okay, we 1 2 3 4 5 6, but what we wanted is we wanted vice captain, coach, and captain should be sitting like this, right? So they might sit anywhere, right? They might sit here also, let's say vice captain, coach, captain, but they cannot sit like this. Some other team member cannot come in between them, right? They should always be together. This is clear, right? So consider this 3 as one place, okay, or one person or one unit, and consider the remaining 3 as 3 units. So this 3 plus 1 will become 4 units. And if I wanted to arrange these 4 units in 4 places, how many ways are there? 4 factorial ways are there, right? Because 4 in the first position, 3 in second position, 2 in another position, and 1 is in the last position. So this is 4 factorial ways. But this we have
I have a
considered as
question.
1 unit, right? But this is not 1 unit. These are 3 different units, right? Right? But internally,
I have a question. Since this is in a circular order, shouldn't it be n-1 factorial rather than 4 factorial?
I have shown it for linear currently.
Okay,
I will
okay,
go to the circular later.
Okay.
Okay, because it will become like directly stepping into another concept. So I'm just showing you in this for linear combination. I'm showing you this, and internally these 3 people can be arranged in 2 factorial ways.
Yes, sir, got it. Thank you.
Right? Okay, fine. Okay, so it is 4 factorial into 2 factorial ways. Okay, similarly, if I wanted to arrange these 6 people, 6 members in circular table, what will happen? Again, what I'll do, I will make these 3 people, 3 team members separate unit, and one unit as captain, vice captain, and coach. Okay, so these are the 4 units or 4 members. How many ways I can arrange these 4 members in circular permutation? In 4 minus 1 factorial ways, which is nothing but 3 factorial ways, right? And internally these 3 members can be arranged in how many ways? 2 factorial ways when the coach position is fixed in the middle, right? If it is not, if that condition is not there, then how many ways are there? If I wanted to see the coach, vice captain, and captain together, if only that condition is there, in that case the answer will be 3 factorial into
3 factorial.
3 factorial, right? Okay, and if I wanted to arrange 6 members in circular table, what is the answer?
minus 1 factorial.
6 minus 1 factorial, which is 5 factorial, right? Okay, nice. I think you guys are okay with this permutation, combination, and probability thing. I just then it's good for me not to explain very basic things. Okay, that's fine. Okay. Okay. So can we move into the probability questions, which is what I feel. Conditional probability, maybe we will see conditional probability on some other day, because it will have conditional probability plus Bayes theorem. Maybe I can have one more session, okay, maybe after Wednesday, maybe by next week, or I will tell, and that will be completely on conditional probability, Bayes theorem, and whatever doubts in general you guys will have. Okay, so today I'll see some probability questions, maybe simple ones from shall we solve one or two permutation combination problems also? Okay, maybe I wanted to see. The problem is we do not have much time, right? So that's why I'm rushing. Actually, I don't, I don't teach that fast, but we don't have much time.
Sir, we have math session as well at 8
Yeah,
o'clock.
8 o'clock.
Yeah.
Okay.
30, I think.
On 8:30. 8:30.
8:30, no? Okay,
Yes.
then we will do like quick, I won't do much things, but I just wanted to solve like 4-5 problems, total of 4-5 problems. Maybe 15-20 minutes I'll take. Okay. And why it's coming like this? Okay, what will be the answer to this question? A man desires to throw a party for some of his friends. In how many ways can he select 5 friends from a group of 15 friends? If the 2 of his friends, say A and B, will not attend the party together. So first of all, tell me, is this a question of permutation or combination? This question is visible to you?
Yes.
It's combination.
Combination.
Right. So he has to select 5 friends out of 15. But the condition is the 2 of his friends, say A and B, will not attend the party together. So how many ways he can select the 5 friends? So can you just tell me? So okay, this is the condition, right? He has to select 5 friends from 15, which include A and B also. So if they don't want to attend the party together, okay, how will you solve this question? Okay, just tell me how many ways are there to select 5 friends from 15?
15C5.
15C5, right? So if they don't want to have party together, how many ways will be there?
14C5.
How? 14C4
14C5.
into 2.
Yes, I think that is the correct answer. So yeah, so let's say you think not 14C, I think it's 13, right? So consider that okay, how so it should be 13, right? So if I exclude this A and B, how many
Both.
friends I left with?
13. Yes.
So and I'll select 4 friends, right, out of 5.
Out of
Right?
5.
So it will be 13C4, right? And among these two, I'll select only one for
1
this extra friend, right? So how many ways
into
are
2.
there to select this? 2C1, right? Which is again 2. So it is 13C4 into 2. That should be the correct answer, right? Do you understand this thing?
Yes, yes.
Everyone?
Yes.
If any doubt is it, just
Yes,
let
sir.
me know. Okay.
No, I didn't understand 13C4.
Sir, in this case, you are telling either A
No,
or
but
B will
the
be
answer.
there.
Sorry?
In this case, you are telling either A or B will be there among 5. But they have not given any condition like that, no?
No, the thing is, okay, but I don't know why this answer is wrong. I'll see. Okay, let's see. A man desires, so he is going to throw a party and he has to select 5 friends. And if 2 of his friends will not attend the party together, that means if A goes to the party, B will not go to the party, right?
Correct. So it can be 15C2 minus 1. That one combination is where A and B together.
15C?
15C5 minus 1, in which that combination is A and B together.
No, I don't think so, right? It should not be like this, right? See, if 15C5 means all the possible combinations will be there, and how you can say that only one combination is from A and B?
In one of the combination only A and B can be together, no?
No, it can be anything, right? We'll have more such combinations.
So it
right?
is combination, not permutation.
Haan.
So
Haan, correct,
if
correct.
you
Haan.
so if you take combinations, then that could be one combination where A and B together.
Okay, okay. Let's try out with the 3 people. Okay, 3 people are there. Maybe not 3. Okay. How to do this? Just a minute. I think where I'm doing the mistake, I'm not understanding. But okay, but whatever your argument is, only one thing, right? One combination. This is wrong because in the 5 people, right? In 5, when I'm selecting 5,
Yes, I got it. That is not correct.
that is not only one case. There may be multiple cases.
Correct.
Right? To select A and B among 5. But the answer, okay, but this answer is not correct. We need to see which is.
So can we take 15C5 minus 15C2? Like 2 people are not attending, so we can minus it from the whole thing.
15C 5 minus
15C2.
No, that will not be the case. Yeah, but I think this should be the correct answer because the other 3 have selected 4 people out of others, and okay. I think okay. We are excluding that cases where A and B is also not the part of it, right? Correct?
Yes, yes.
14C.
Okay. 1 minute. Just give a minute. Okay, I'll just. Yes. So this is correct. See, this thing is correct. We are missing with this 13C5. Okay. So I'll tell you how to. Okay. So there are 15 people, right? Among which A and B is also there, right? Correct? And we have to select 5 friends. So there will be 2 cases. So case 1 is A and B are not among 13 people, right? So in that case, how many ways are there? 13C5. This is possible, right? In this this number of ways are there where A and B are not there in the party, but that is fine for us, right?
Yes, yes.
Right. So these are the ways in which I can select 5 people in the remaining 13 people, in the remaining 30. There is one case where I will have A and B should not be together. So we will select either A or B for party, right? So in that case, the 4 people will be selected from remaining 13, and one is going to select from A and B, right? So here, what is happening? 4 among the remaining 13, and one of from A and B. This so that means A or B, right? So that means A and B are not going together, right? And here definitely A and B are not going together, right? Because A and B are excluded from this number of ways. So this should be the
Both are
final answer,
absent.
right? Okay, here A and B are not there. Here one of A or B is there, right? But this is acceptable, right? These 2 cases are acceptable, right? Because we don't want A and B together. Here A and B are not going, that means they are definitely not there in the party. Here one of them is there, that means the other condition which we wanted is satisfied. So this should be the number of ways, and I think that should be the correct answer. You can check. So, right, so 13C4 to 2C1. These are 1430 ways, and here which is 1287. So if you add them, it's going to be 2717. All of you understand this?
This is the answer.
Yes,
and
sir.
Yes, yes.
Is the answer, right? See, 2717 will be the correct answer, right? No confusion. Okay. I think, okay, I'm thinking like there is no confusion. Okay, let's solve this question then. How many 9-digit number can we form such that they read the same way from either of the side? That means number is palindrome. Palindrome, you understand, right? Palindrome is what? Palindrome will be there for letters also, but here we are asked for numbers. So 131 is palindrome. Okay, or maybe 25352. So if I'm reading from this side, it is 25352. If I'm reading from this side, it is 25352. Same, right? It's called palindrome. So that means the other 2 sides, so or other the left side of the digits will be same as that of right side of the digits. That is the meaning of palindrome. So if I wanted to have how many digit numbers? 9-digit number. So how many ways are there? Okay, so let's do for 5. Maybe let's do for 3. If I wanted to find a 3-digit number which is palindrome, and by using this digits 0 to 9, how many ways I can do that? So for that, what I have to do? Yeah. So for that, what I have to do is I have to fix this position, right? So okay, here how many numbers I can select? How many ways are there?
10.
10.
10 ways are
same.
there, right? 10 ways
Yeah.
are there, right? Okay. And how many ways are there to fill these places?
9.
9.
9.
9, right? Correct? 9 or 10?
How many 9?
See, how many 9-digit numbers can form? Says that there is. Why 9? We can use 10 also, right? Because repetition is fine, right? So, okay. 1, 1, 1 can be read same from left side and can be read from same from right side, or maybe 2, 2, 2, 3, 3, 3. If you use 9 here, that means we are, we are not counting these cases, correct? Where each of the digit is same. So I will have 10 ways, right, to fill this place. And how many ways are there to fill this place now?
Excuse me, sir.
Yes.
Sir, if we take 10 ways, then that means we're using 0 also. But if a digit starts from 0, will we consider it as a 3-digit number? I mean, 0, 1, 2.
Correct. Correct. That is the thing, right? So I cannot consider that as the 3-digit number. So how many ways are there?
9.
9 ways, right? Okay. So if I fix this two position, how many ways are there to fix this position?
10.
One way, right? The third last one, because if I have selected this number, I have selected this number, the same number will be repeated here, right? To have palindrome, correct?
Yes.
So I need not to choose. I should not have the number of ways here. So the total number of ways are 9 into 10, right? So for 5-digit number, what will happen? I will select this position. How many ways are there?
10.
10. How many ways are there here to select this position?
10.
How many ways are there here?
9.
So once I fix these three positions, how many ways are there to like to fill this
1
position?
and 1 only.
1 into 1, because the same number will be repeated here, same number will be repeated here. So once I fix number here, there is no way I can select the other number, right? There is only one way, because I have to use the same number here. So total number of ways here are 9 into 10 to the power 2. So this is in case of 3, this is in case of 5. Okay, same for 9-digit number. How many ways should be there? 9 into 10 to the power 1, 2, 3, 4, 5. 4, right? Because here it is 10, 10, 10, 10, and 9. So 9 into 10 to the power 4. Similarly, here is 1, 1, 1, and 1. That. So the correct answer should be 9 into 10 to the power 4. Right? This is the correct answer, 9 to 10 to the power 4. But do you understand, right, why we have used 9 there instead of 10? Because we wanted that digit to be 9-digit number, right? If I use 0 at the first position, that wouldn't be a 9-digit number, right? Okay, so I think still we have left with the probability. Maybe we'll have one more session where we'll discuss. Maybe we'll take forward this permutation, combination, and probability there. Tomorrow it won't be. You might not be having probability. We'll cover week 9 to 12 tomorrow. Okay, will that be okay? I will arrange one more session maybe by next week on probability and conditional probability, and maybe whatever doubts we'll have. Okay. Okay, fine. So we'll discuss some more questions tomorrow on that day. Okay. Thank you.
Thank you,
Thank you for joining the session.
Thank you, sir.
Good night, brother.